Hi everyone, this is Ms. Peters, and in this video I'm going to go over AP topic 7.13, which is how pH and solubility relate to one another. As a reminder, pH is a measure of how acidic a substance is, or the concentration of hydrogen ions. That's why it's called pH. What's the power of hydrogen ions? And solubility refers to how well something dissolves. And it's simple, but a lot of people mess up. What does it mean if we say something's solubility has gone up? That means more is dissolving. If we say solubility has gone down, that means less has dissolved and it's more solid. So an increase in solubility means more solution. A decrease in solubility means it's more solid or more solute. And it's easy to flip the differences between those. So solubility equilibrium refers to the equilibrium. So when a reaction, the rate of the forward reaction equals the rate of the reverse reaction, is established when a solute is dissolved in solution. So let's say, for example, we have CaF2 and I dissolve that in solution. It's eventually going to get at an equilibrium where of calcium ions and fluorine ions. Now this is not a completely soluble solute, so there will still be some solid or solute, and then our ions will be formed in solution, and eventually it'll get at that equilibrium. And if we change the pH of the solution that this is dissolved in, it can affect the solubility of it. And so how? Let's look at this first example for magnesium hydroxide. So magnesium hydroxide is partially soluble, and when it dissolves, it will form one magnesium ion for every 2 hydroxide ions, because it's MgOH2. And so this kind of goes back to Le Chatelier's principle. What would happen if I increased the number of hydroxide ions? That means I increase the pH, or I add a basic solution. That means I'm adding a product. If you increase the amount of product, the reaction is going to shift left or favor the reverse reaction to get back into equilibrium. And so if it's favoring the reverse reaction, we're making more solid. And if we're making more solid, that means that solubility has gone down or it's decreased, because there's not as much dissolved anymore. Just the opposite. What if I decreased the pH of this solution? That means if I'm putting it in something acidic. Now, acidic solutions have lots of hydrogen ions and little hydroxide ions. And so there's a few ways that you can think about this. Hydroxide is a product over here. So if I want to think that acidic solutions have little OH, just one way to reason through this is if I decrease the amount of product, my reaction is going to shift to the right or favor the forward reaction to make more product. If it's shifting to the right, that means I'm making more ions and I'm going to have less dissolve, because it's got to, come from somewhere. And so if less is dissolved, then solubility goes up because less is dissolved. Or if you want to think about this in terms of hydrogen ions, when you put this in an acidic solution that has tons of H ions, the H ions are going to react with the OH ions. They react and they will form water. But regardless, that's still going to decrease the amount of hydroxide ions, get this reaction out of equilibrium. It's favoring the forward reaction or shifting right to make up for that there's less hydroxide in the solution. So I hope that makes sense. So this is why if you've ever taken milk of magnesia, like if you're having heartburn, stomach issues, so milk of magnesia is MgOH2, it will dissolve in your stomach. If you're having heartburn or stomach acidic issues, that means you have excess acidity. You've got too much H ions. And so this is essentially how this works. And it'll dissolve in your stomach and, I don't know, do a bunch of biology, make you feel better. Okay. So this applies to salts with other types of anions. So this first example being silver phosphate. Silver phosphate, Ag3PO4, is more soluble in acid than in pure water. So let's look at, this is when you have silver phosphate, what it will break down to form. 3 silver ions and a phosphate ion. And so what happens? Phosphate ion is a strong base, and it will react with hydrogen to form the, that's not phosphide, I don't remember what that's called, but it will form that ion. This is the reaction that happens when you put it in something acidic. So if I have this in equilibrium and I put it in an acidic solution, a second reaction happens, which is this. Now, what happens if this reaction is going on? What am I using up? I'm using up my phosphate ions, right? This is not the same as that. So these are getting used up, these phosphate ions. They're getting used up, that means over here, back in the original reaction, their concentration has gone down because they're being used in this reaction. If they are going down, equilibrium will shift and it will favor the forward reaction, or it's going to shift right. And if it's shifting right, that means what are we going to use up? We're going to be using up our solid. And so we say if there's less solid, that solubility increases, or more gets dissolved. Now, silver chloride has the same solubility in acid as it does in pure water, so acidic solutions don't make any more dissolve. And the reason why, so the chloride ion is a very weak base because HCl is a very strong acid. And so no HCl molecules are formed. It might help if you look at, here's our original reaction. So when we add this to something acidic, we're adding it to a bunch of hydrogen ions. The H and the Cl aren't going to react together. And so it doesn't change the concentration of chloride ions. So if the concentration of my ions are not changing, then equilibrium will not change and the same amount will stay dissolved. So that doesn't affect it. So the general rule for solubility and pH is if anion X is an effective base or a strong base, what does that mean? That means that the acid from which it was formed is weak. So for example, HF is a weak acid. So if my anion is F minus, that's an acidic or an effective base. I've got a list of effective bases below, but they all come from weak acids. So if that is your anion, then the salt, just the ionic compound, will have increased solubility in acidic solutions. That again means more will dissolve. You'll have less solid, more will form ions. The most common effective bases that you're going to see, hydroxide, sulfur, carbonate, chromate, oxalate. And yes, the key is that they are just much more soluble in acidic solutions than in pure water because they will react with the hydrogen ions. While if your anion comes from a strong acid, it's not going to react with the hydrogen ions and equilibrium won't shift. So let's do a practice question really fast. Which of the following insoluble salts will be substantially more soluble in nitric acid, which is this, than pure water? I'll give you a minute. Hopefully you said it will not be AgCl because AgCl forms Ag and Cl minus. Cl minus is the base from HCl, which is strong. So not that one. It's also not going to be AgBr for the same reason. HBr is a strong acid. But carbonate is more soluble in an acidic solution like nitric acid because CO3, 2 minus, comes from that's a conjugate base for this acid. And that bicarbonate, and that's not a strong acid, and phosphate will as well. So I hope this video was helpful and that you enjoyed it.